Today's topic is decomposition based on software versus engineering-based physical modeling characteristics. Now, as an engineer, which is what I am, I frequently think of my decomposition of systems on a physical component basis. If I'm modeling a jet engine, I'm going to think of the cowling, the turbine blades, the propeller shaft, heat exchangers, all the things of that nature, and I'll probably decompose the model into those components, some combination thereof. As a software engineer, a different hat that I wear on occasion, I'll think of it in terms of data exchange, memory management, efficiency of algorithm, and I will think, well, how should these things go together to generate the most efficient code? You probably already see there can be, but does not need to be, a potential conflict between these two constructs. What is logical from a component-based decomposition for the engineer may not be the most efficient from a software perspective. So, how do we resolve those two things? Well, the first one from a software perspective is the ability to reuse subsystems and function. This should be obvious to any software engineer. If you have reusable functions, this can actually be used to interface in multiplications in your generated code, your handwritten code. So that's a minor part. The second part, though, is a concept of multiple boundaries. So when I'm developing an algorithm in Simulink, normal environment I develop in, it's a model-based design environment, I as an engineer can draw my boundaries for the components, my engine, my turbine blades, my shaft, and they can be decomposed in that fashion for me. I then hand that same model off to the software engineer, and they can then take that same model and impose boundaries on the model to say, well, okay, he has given me, he being me, he has given me these 7 different components, but really I want to draw a box around these 3, another box around these 2, and then the final 2 will get boxed up individually. So using a model-based design architecture, I can take those models and recompose them in different fashions for the engineer versus the software person, thereby gain the best of both worlds. Now, caveats in there, of course, there will be times when the needs of the software engineer says, well, we really need you to move this from here into this over here, and that will have to happen, but there should always be that attention to the how understandable will it be after you make that move. Consider the trade-off of clarity in development versus efficiency in execution. 90% of the time, clarity, in my mind, trumps efficiency, but for that 10%, it'll be what it is. Hope you have a great day.